So the chain rule is used when you have a function of a function of x. So basically when you've got one function of x inside another one. So for example, something might be like 3x plus 5 to the power of 2. So this would be a function of x and then it's to the power of 2. Obviously on that one it isn't too bad because you could expand your brackets out. But it might be something like x to the 4 plus 3x to the power of 7, in which case you wouldn't want to be expanding 7 brackets. So it's an easier way of differentiating things like that. Or it might be something like ln 5x plus 3. So again, your first function of x is the 5x plus 3, and then you're doing ln of that. So it's whenever you've just got a function inside a function, basically. So I'm going to go through the long way of doing it, and then I will go through the quicker way that you can do it. So it's the same thing, but just a quicker way of realising how to do it. So first of all, if I start with, I'm just going to go with the one I wrote here actually, to be honest. So 3x plus 5 squared. So you set u equal to the first function of x. So you would say u equals 3x plus 5. And then we know that this is u, so it now becomes u squared. So I'm just going to let this be equal to y and just say that y equals u squared. So to do the chain rule, you just differentiate both of these. So you would differentiate du by dx, so you're going to get 3. And then you differentiate dy by du, and that's all in terms of u. So you just bring the power down and make it 1 less, so that would be 2u. So to get dy by dx, the chain rule is just that you multiply du by dx by dy by du. So basically these bottom two here, just times those together. So 3 times 2u is 6u. And then the only last thing to do is that you want this in terms of x, because it's dy by dx, and this is in terms of u. So you need to replace the u with what we know u is equal to, which is 3x plus 5. So it would be 6 bracket 3x plus 5. So I'm going to do the next example that I said about at the top up here. So x to the 4 plus 3x to the power of 7. So if I just rewrite that quickly, that is an x. So u is equal to x to the 4 plus 3x. So therefore y equals u to the power of 7. So again, you would differentiate both of these. So it would be du by dx, because this is all in terms of x. So that would be 4x cubed plus 3. And then this one would be dy by du, because it's in terms of u here. So if I differentiate that, you get 7u to the power of 6. So chain rule, you just times those two together. So it would be 7u to the 6, 4x cubed plus 3. Or obviously you might have done it in a slightly different order. You might have 7, this bracket, and then u to the 6. And then last thing is, this is dy by dx, so you want it all in terms of x, and this is in terms of u. So you replace the u with x to the 4 plus 3x. So it would be 7x to the 4 plus 3x to the power of 6 times 4x cubed plus 3. So then the other example I said about was this one here. So ln 5x plus 3. So on this one, you would say that u is equal to this function of x here. So u would be 5x plus 3. And then you differentiate, y equals ln u. Then you differentiate both of those. So du by dx would be 5. And then on this one, it would be 1 over u. So times those bottom two together. So you're going to get dy by dx equals, remember when you times the fraction by a whole number, you just times the top bit. So it would be 5 over u. And u is actually 5x plus 3. So it would be 5 over 5x plus 3. So I did mention at the start of the video just a quicker way that you can do it. So by all means, there's nothing wrong with doing it the way we've just done it. Especially if you are someone who tends to make mistakes. If you do things in your head, you might rather just carry on writing it all out like we've done up here. So if I just do another example of one and show you a slightly, just a quicker way to think about it. So I'll do this one here. So we've got sine to the power of 4x. So that is the same thing as sine x to the power of 4. So kind of ignoring that for a minute, if it was just x to the power of 4, to differentiate that, you would bring the 4 down and make the power 1 less. So it would be like that. Or you could write that then as sine cubed x, like that. But what you then need to do is times what you get here. Because of the chain rule up here, we're timesing by what you get when you differentiate what's actually in the bracket. So going back to this example, you now need to times that by what you get when you differentiate this function of x, so the part in the bracket you normally. So when you differentiate sine x, you get cos x. So you would times this by cos x, and you just put that all together. So it would be 4 sine cubed x cos x. Then if we do another one, so say if it was, I'll just find one from the book I've got in front of me. So say if it's 5x squared plus 1, it's the power of a half. So again, if you were going to differentiate that, you would bring the power down in front and then make it 1 less. So it would be that, but then you need to times that by what you get when you differentiate this. And when you differentiate that, you would get 10x. So when you do a half times 10x, that's going to make it 5x. So it would be 5x and then 5x squared plus 1 is the power of a half, like that. I'll just try to think if there's any other. Let's just go for one more. So say if it was, I will do another ln one. So if it was x squared plus 8x, something like that. So when you differentiate ln, if it was ln x, it just goes to 1 over x normally. So it would be 1 over x squared plus 8x, but then you need to times that by what you get when you differentiate the bracket. So that would be 2x plus 8. So remember, when you times a fraction, it's just the top bit. So you would get 2x plus 8 over x squared plus 8x. So that is the chain rule. Hopefully that has made it a bit clearer for you.